Hello everybody and welcome to your Unit 1 Lesson 3. We are continuing with our ecosystems unit here, and today we're going to be talking about the biogeochemical cycles. So there's a few that we're going to have to be able to look at and understand. So after this lesson, we're going to be able to describe how water cycles within ecosystems, explain how carbon cycles within ecosystems, describe how nitrogen cycles within ecosystems, explain how phosphorus cycles within ecosystems, and then also discuss the movement of calcium, magnesium, potassium, and also sulfur within ecosystems. So let's go ahead and jump right into it. So the first biogeochemical cycle that we're going to be talking about today is the hydrologic cycle. And this is what moves water through the biosphere. Okay. So when I say biogeochemical cycle, we're just talking about the movements of matter within and between ecosystems. And the hydrologic cycle specifically refers to the movement of water through the biosphere. Okay, so here's some, just a depiction of how water moves through the hydrologic cycle. So these pictures in your textbook and then in this PowerPoint are going to be really good references for you guys during this lesson. And also as you prepare for your first test. So we can kind of see, so the movement of the arrows are showing us how the water actually moves through the cycle. So first we can start with the sun. If we look at the sun here that's heating up the earth, this heating causes evaporation. So the evaporation, it comes from our water source up into the atmosphere. Also plants do transpiration, and also it evaporates from soil as well. So as we have this evaporation and then transpiration up into the atmosphere, we have the condensing of the water in the atmosphere, which then eventually falls back to the earth as precipitation, right? And then the plants will uptake that precipitation as well. Remember that an essential component of photosynthesis is actually water. And then if plants aren't taking it up, a lot of times water will be infiltrated into the ground, which will then go to the groundwater, and this is where we actually get a lot of our drinking water from. And then anything else can also potentially be surface runoff. So anytime it rains, anything that's not infiltrated or taken up by plants or vegetation will run into rivers and streams and eventually make its way to a larger body of water. So the important thing to know about the hydrologic cycle, or really any of these cycles, is that if you can follow the arrows to where everything goes, you should be able to follow the water. And it is cyclical in nature, right? So like this, let's say this is a lake right here, the water from this lake that's evaporated makes its way into the atmosphere and then eventually makes its way back into the lake. So it's cyclical in nature. And this occurs all day, every day on our planet. So just a few things to be aware of and to be able to define. So in the hydrologic cycle, we've got transpiration, and that's the release of water from leaves during photosynthesis. So if plants are doing transpiration, they're releasing the water. Evapotranspiration is the combined amount of evaporation and transpiration. So the plants are releasing it, but also if it's hot out, any kind of water that are on those leaves can also be evaporated. And then runoff is just water that moves across the land surface and into streams or rivers. Next, we're going to talk about the carbon cycle, and this is just the movement of carbon around the biosphere, so the element carbon. So again, just like our water cycle, we can kind of just follow the arrows and see where carbon is emitted into the atmosphere and then comes back down and is held in the ground. So producers, so things like plants, will take up carbon from the atmosphere via photosynthesis and then also pass it on to consumers and decomposers. So plants will take up the carbon and then we in turn will eat the plants, and that's how carbon can cycle from plants to humans and plants to animals. Some of the inorganic carbon sediments precipitate out of the water to form sedimentary rock, while some organic carbon may be buried and become fossil fuels. And then respiration by organisms returns carbon to the atmosphere and to the water. So when we respire, remember, we breathe in oxygen and we breathe out carbon dioxide. So when we breathe, or when animals breathe, we are actually returning carbon to the atmosphere. And then the combustion of fossil fuels and other organic matter will return carbon to the atmosphere as well. So again, if we can just follow the arrows, we should be able to kind of identify where the carbon comes from and is emitted into the atmosphere, and then how it comes back into the ground level. So fossil fuels and trees, anything that consumes carbon or takes in carbon and stores it, those things are going to be referred to as carbon sinks. So if it will hold carbon, if it'll take in carbon and hold onto it, it is a carbon sink. And one of the largest carbon sinks for the Earth are basically these fossil fuels, which we are extracting, but also our plants can be carbon sinks as well. The next cycle we're going to talk about is the nitrogen cycle, and this one's probably the most complex because there's a lot of different chemical transformations that are happening during the nitrogen cycle. So just a reminder on macronutrients, those are one of the 6 key elements that organisms need in relatively large amounts. And these include nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. Just a fun fact, magnesium, if you guys are depleted in magnesium, it can cause your stress levels to rise. So if you're really stressed out and you have a lot of anxiety, you might need to supplement with some magnesium. But anyway, nitrogen and phosphorus are going to be incredibly important because those are the components of our DNA, right? And our DNA is basically the building block of our entire life. A limiting nutrient is a nutrient required for the growth of an organism, but available in a lower quantity than other nutrients. And then our nitrogen cycle is going to be the movement of nitrogen around our biosphere. There are 3 things we need to be aware of in the nitrogen cycle. The first is nitrogen fixation. And this is the process that converts nitrogen gas in the atmosphere, so in the form of N2, into forms of nitrogen that producers can use. So N2 is nitrogen gas. And during fixation, we've got that gas being taken out of the atmosphere and then converted into a form that producers can use. During nitrification, the conversion of the ammonia, so that's NH4 plus, into nitrite, which is NO2 minus, and then into a nitrate, which is NO3 4 minus. So during nitrogen fixation, we're converting, again, gas in the atmosphere into forms of nitrogen that producers can use. Nitrification, we're converting from ammonia to nitrite and then to nitrate. And then in assimilation, the process by which producers incorporate elements into their tissues. So again, we do have to have nitrogen, but we cannot make it ourselves. So when we eat plants, we are getting that nitrogen from the plants. And when we assimilate it, that's when we incorporate that into our own tissues. All right. Some other things to be aware of: mineralization is the process by which fungal and bacterial decomposers break down the organic matter found in dead bodies and waste products and then convert it into inorganic compounds. Ammonification is the process by which fungal and bacterial decomposers break down the organic nitrogen found in dead bodies and waste products and convert it into inorganic ammonium. Denitrification is the conversion of nitrate into a series of steps into the gases nitrous oxide and eventually nitrogen gas, which is emitted into the atmosphere. So when we follow the nitrogen in these biogeochemical cycles, the denitrification that's happening is when the nitrogen is returned back into the atmosphere. And then leaching is the transportation of dissolved molecules through the soil via groundwater. So basically, nitrogen that's in water can leach through the soil, and that's just a process we need to be aware of. So here is your depiction of your nitrogen cycle. So again, this is going to move nitrogen from the atmosphere into soils through several fixation pathways that we need to know, including the production of fertilizers by humans. And then in the soil, nitrogen can exist in several forms. Denitrifying bacteria release the nitrogen gas back into the atmosphere. So again, we should be able to look at these depictions and be able to follow what's happening. Okay. The phosphorus cycle is the next cycle we're going to talk about, and that's when the phosphorus cycle moves between land and water. So phosphorus cycle is a little bit interesting because this is the movement of phosphorus around the biosphere. And an algal bloom is just a rapid increase in the algal population of a waterway. If a waterway is hypoxic, that means it is low in oxygen. And a dead zone occurs when oxygen concentrations become so low that it kills fish and other aquatic animals. So why are we talking about hypoxic waters when we're talking about phosphorus? Well, phosphorus is a nutrient. And so if a lot of phosphorus gets into a waterway, what will happen is that algae will bloom very quickly and large amounts of it. And when the algae bloom, because there's an excess of phosphorus, eventually once that phosphorus and that nutrient dies out or goes away and is limited, the algae will start to die as well. Once they run out of their food source, they'll start to die. Well, the job of bacteria in the water is to act as decomposers. And so once the algae is dead, the bacteria will act as a decomposer and start to break down the algal blooms that have died. And in order to do that, they're respiratory, so they need oxygen. So they will take the oxygen out of the water. So increased phosphorus in a waterway is bad. So if we have more phosphorus, we've got more algae. And then when the algae dies, the bacteria will break it down and it will starve the waterway of oxygen because it's using up all that oxygen to act as a decomposer. So the phosphorus cycle is unique because it begins with the weathering or the mining of phosphate rocks and the use of phosphate fertilizer. Okay, and this releases phosphorus into the soil and the waterways, which then can lead to hypoxic waterways. The phosphorus can be used by producers and subsequently moves through the food web. In water, phosphorus can precipitate out of solution and form sediments as well, which over time are transformed into the new phosphate rocks, and then the cycle continues. Okay, so we need to know that during the phosphorus cycle, that begins with the weathering and the mining of phosphate. Now, the phosphorus cycle does not have an atmospheric component. So if you guys look at this one, phosphorus does not travel in the atmosphere. It's limited to the land and the water. Calcium, magnesium, potassium, and sulfur also cycle in ecosystems. And our sulfur cycle is the movement of sulfur around the biosphere. So our sulfur cycle is our very last one we're talking about. So most sulfur exists as rocks. And as these rocks are weathered, kind of like our phosphorus cycle, they release the sulfate ions. And then the producers are able to take up sulfate ions and assimilate those, similar to our nitrogen cycle. The assimilated sulfur will then pass through the food web. Volcanoes, burning of fossil fuels, and the mining of copper also will put sulfur dioxide into the atmosphere. And then in the atmosphere, the sulfur dioxide will combine with water to form sulfuric acid. And then this sulfuric acid will then be carried back to Earth when it rains or snows. So this is where we kind of get acid rain from. And we'll talk about acid rain a little bit more when we get to atmospheric pollution. But it's not a good thing. Acid rain is definitely a production of the combustion of fossil fuels. So again, we should be able to basically just follow the arrows and watch and see kind of where the source of the sulfur is coming from and then where it's going. So like here we have our volcanic emissions. They're coming from the volcano, so the volcano would be the source, and then they are being deposited in the atmosphere. And then of course we have this reaction with water, and then we have acid rain, so the sulfur is falling back into the land, and it'll be infiltrated. This is also kind of back into the hydrologic cycle, or it can run off into our waterways. So the main takeaway from today, we do need to kind of focus a little bit on the nitrogen cycle, just so we know the difference between nitrogen fixation, ammonification, and all of that. But for the most part, for these cycles, you should be able to take a look at the diagrams and be able to follow where the source of the mineral or the element is coming from, and whether or not it's going to the atmosphere or going into the waterway. And we should be able to do that by following the arrows. But if you guys have any questions about that, be sure to let me know. And that's the conclusion of your lesson 3.